All right, in this problem, we've been asked to create a frequency distribution of this random sampling of a population of heights of male college students. And this is in inches. And so we've been given a bunch of data values. We're trying to create a frequency distribution for that data. And so what I want to do is I just want to create my table. I have my value, so I'll call it my X value, and then I'll have my frequency. Okay, and let's find a smallest value here. So far I'm seeing 68 is my smallest. If I keep going, 66 is going to be my new smallest. 67 is bigger than that. It looks like 66 is my winner. All right, so 66. And how many 66s are there? As I go through here, I'm only seeing that one. And I don't see any other 66s, so it only appears once. All right, now let's look for 67. If I'm looking for 67, I'm just going left to right, and I'm scanning here, and I'm actually putting my pencil over each number because that's the only way I know to actually focus your attention on each number, especially while I'm talking like this. There's 1, there's 2, there's 3. I think that's got all the 67s. I'm a big fan of putting some sort of check mark over things as you find them, because then when you're done, you'll know if you've actually accounted for all of your data. All right, so now I'm going to do 68, and I'll find 1 there. If I keep going, I'm going to find a second one down here, and I think that's all of my 68s. 69, I'm going to find 1 there. I'm going to keep going. I think I only have the 169. I'm going to do a second pass just because I was a little bit fast there, and I'm not 100% sure. All right, so it looks like I only have the 169. I'll do 70. I've got a 70 there, so 1. It doesn't look like there are a lot of 70s here, so it looks like I got another 70 and another 70, so I got 3 total. All right, now 71. What do I have? I've got 1, 2, 3, 4, 5, 6, and 7. So 72. 1, 2, 3, 4. 73, we're coming down the home stretch. We got 1, 2, 3, 4. Oh, I may have missed a 72. I've got 1, 2. We got 1 there in the upper left. No more there. A second one. A third one, and a fourth one, a 472, and that's what I wrote down. I must have forgot to put the check mark there. But this is why you put the checks, is so that you can remember these things. Now it looks like I might have forgotten to do the same thing with the last 73, so let's check that again. And 73 is 1, 2, 3, and yes, 4. Getting a bad habit of not putting those down. All right, now 74. There's a lot less to search at this point. I go up here, and I've got a 74, 1, just 1. And then I've got a 75. And if I'm looking for 75, I've got 1 there, 2. That looks like it. And so that is my frequency distribution. Now I can do a few things with this frequency distribution because there's several other ways that I can represent this data. But to be clear, we're done with this problem. This is what they asked for. But I could do a few other things with this. let's start out by doing a stem and leaf plot. So let's convert this to a stem and leaf plot. Okay. Well, the stem and leaf plot, it had my tens, right? It had my tens, and it had my ones places. And so the way I would write that is I would write that as a 6, 6 for my 66. Then I'd have a 67. I'm going to put commas in between my numbers. 7 and 7 for my 3 sevens. I'd have 8 and 8 for my 2 eights. I'd have 9 for my 1 9. Then the next 10 slot would be a 7. And so I'd have a 3. I'm sorry, not a 3. I'd have a 0 3 times. 0, 0, 0. I'd have a 1 7 times. 1, 2, 3, 4, 5, 6, 7. I'd have a 2 twice. I'm sorry, 4 times. I'd have a 3 4 times. I'd have a 4 once. And I'm going to have to do that teacher with a tablet thing. Oops. That teacher with a tablet thing and slide everybody over just a little bit. Because I'm running out of space. It's horrible. Okay. So now I've got my 1 4, and then I've got my 2 5s. And so the stem and leaf plot may not be the best choice for this particular data set, because this particular data set is kind of restrained to just 60s and 70s, and there are a lot of 70s and a lot of repeats in those 70s. What's another way we could represent this data that we've talked about before? We could do a histogram of this frequency distribution. And if I did that, what would I have if I wanted a histogram of this? I'd have tick marks at 66 through 65 or through 75. So 66, 67, 68, 70, 80. Nope. I want to go by tens. I cannot go by tens. 71, 72, 73, 74, 75. All right. And so that's the range of my data, or the range over which my data exists. And then on this y-axis, I'm going to go, 1 through 7 or 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And we can go from there. Okay, and so if I've got the 0 and the 5 marked on the height, I go to 66 and I'm at 1. And so I put in a bar at height 1 over 66. I go to 67 and I'm at 3. And so I go 1, 2, 3. That's the height of that bar. 68, I have 2. And so I'm down to 2 there. Then 69 and back down at 1. '70, I'm all the way up to 3 again. 71, I am up to 7. So all the way up to there. $72, I'm at 4. $73, I'm also at 4. 74, I'm back down to 1. And 75, I'm up at 2. And so there's my histogram, or bar chart. Now, from that histogram or bar chart, there's another thing I can do to describe my data. I can say with frequency polygon. And the way that I draw this frequency polygon is I put a dot in the top center of each one of these bars. And from that dot, just connect it to the ground somewhere. From that dot, these students' grades are measured and compared to the distribution of past students' grades. And so what I just did in blue is the frequency polygon. And it can exist independent of the histogram. It's just easier to draw after you already have a histogram. All right, I hope that helps.